So in this video, with the continuity of logical instructions, we will see here further 4 rotate instructions. So out of 4, the first one is RLC, which I'm going to discuss in this video, and further 3 rotate instructions you will get it into the 3 different videos here. So now this RLC is having the meaning of rotate accumulator left. So here the purpose for this instruction is whatever is the content of accumulator, it will be rotated left bit by bit. So first of all, we'll see their opcode here. So the opcode for this instruction is RLC, and here as a operand, this is by default as a accumulator content. So the code for this accumulator register is already enabled or embedded with this RLC opcode. So that is the reason no need to specify here that any operand. By default operand is the part of the instruction opcode itself. So here as operand it should be mentioned none, because by default their operand is accumulator content itself. So now we will see their operation with the example. So for example, let's say that if I am writing RLC, and before using this instruction, if the content of the accumulator is, so this is before data and this is the accumulator register here. So if I am assuming this, that initially carry bit is 0 here, this carry bit is 0 and D7 is 1, then 0, 1, 0, 0, 111. So it means this accumulator content here, it is 1010 means it will be 10. 10 means in the hex it can be written here as a, and this 0111 it can be written here as a 7. So before execution of this instruction as a RLC, the data of this accumulator is A7H and this carry flag status is 0 here. Now if we are going to execute this instruction by this microprocessor, then what will happen? This D7 bit will update this D0. It means this entire content of the accumulator is shifting 1 times left, and this D7 bit values is going to update this carry flag as well as this D0 bit also, and this entire data will be shifted 1 times left here. So now after this, like after execution of this instruction, what will be the content here? So as a content, this will become here, carry flag will be 1 here. Now this D7 values, like this D7 will modify to this D0, and whatever is the value at D6, it is coming to this D7. So this entire data is shifting 1 times left into the circular way. So here this D7 bit will become now 0, then this will become 1, then this will become 0, then this will become here 0, this will become 1, 1, 1, and this will become here 0. So this is the data we will obtain. This is the data we will obtain after execution of this instruction here. So this is the value whatever we obtained, it is after. So after execution of this RLC 1 time, this is the content of the accumulator register here, and this can be 0100. So this will become here as a 4, and this will become here as a like 14. 14 means it will be here E. So this accumulator content, it will become here as a 4EH. So how many times we will execute this RLC instruction, that many times this accumulated data is going to be shifted left side in this fashion, in this circular way. So accordingly we can use this for the programming purpose over there. So now we'll talk about that flag. So with respect to flags, if we will talk with respect to flag here, then it is saying that this sign, 0, parity, auxiliary carry are not affected. Are not affected. Only carry flag. Only carry flag is affected. So as per the rotation result obtained, that carry flag will be affected. So this D7 bit is the bit which is going to be modified this carry flag, as well as this D0 bit. So now again, if you write here further RLC, then again this data is going to be shifted left side with the similar manner whatever I had explained here itself. So how many times we are going to execute this RLC instruction? Those many times this accumulator content is going to be shifted left side with this circular way, and at the same time every time it is going to be update their carry flag also. So this is the operation, how to use this RLC instruction. Now we'll talk about their size. So as a size, it contains of only English alphabet here, so that is the reason their size will be 1 byte only. Now if we talk about that, their machine cycle, so as a machine cycle this requires only opcode, that for the execution of this RLC, that microprocessor need only opcode from the memory chip, and after that all the things is available inside the processor itself. So these all the operation will happen inside the processor itself, and that accumulator register is going to be updated as per the shifting operation, as per this rotation operation, and at the same time it is going to affect only this carry flag. So this flag register, accumulator register, this operation, all these things is happening inside the microprocessor itself. So that is the reason it is required only one machine cycle, that is for the opcode fetch operation from the memory to the chip. So as a machine cycle, it will take only one machine cycle, and that operation is called as a opcode fetch operation. And by default, as we know that for this opcode fetch, it is required only 4 T states here for their execution. So this number of T state will be 4 only here. So by this way, I hope you understand this instruction with much of clarity. Thank you.